So this problem is the same idea as before. We're being told we want the cosecant this time, the cosecant of two angles, and we're given some information. We're given the cotangent of the angle phi, and we're given the cotangent of the angle theta. Now maybe in your example it's a little bit different, but the idea is going to be the same. What may be giving you trouble is I never taught you a cosecant summation identity, right? What do we do with this? Well, it might help you to remember the reciprocal identity first. The reciprocal of cosecant is just sine. You could say cosecant of angle, angle A, for lack of a better idea. Cosecant of A equals 1 over sine of angle A. Now, if that's true, who cares if A is called A, or maybe it's called phi plus theta, right? If it's phi plus theta, no problem, just replace it in both places. Phi plus theta. And you'll see if we can figure out sine of phi plus theta, all we have to do is flip that fraction around and we have cosecant of phi plus theta. So let's go ahead and start doing that. First, we'll deal with the angle phi. And I'm going to use a standard coordinate plane here. We need to figure out, a triangle in, what is that, quadrant 2, I think, right? So I just build a quadrant 2 triangle right here, and give me a little more space. There we go. And let's see. Cotangent is -7. Well, we have to be careful there. What's cotangent? That's adjacent over opposite, right? So there we go. -7 divided by 1 equals -7. And we need to figure out what the hypotenuse of this triangle is. And to me, that looks like the square root of 50. If you do the Pythagorean theorem, you'll see we get that value here. And now it's a completed triangle. I can move on to the next angle, theta. So I'm going to draw another quadrant over here. And in this one, I see that it's in quadrant 1. So there's my quadrant 1 triangle. Here's my reference angle, theta. And I'm going to say cotangent equals 2 over 5. Okay, well that means x is 2, y is 5. I do a Pythagorean theorem to find the hypotenuse, and that's going to be, I think radical 29. Okay, so now my triangles are complete. I'm just going to label this one with an angle. And all I need to do at this point is find, remember, we're not looking for cosecant right away. We're looking for sine of phi plus theta, which according to our identity, sines can't change signs. So I'm using a plus sign, it's the same as before, and can't change signs. We keep the angles in the same order. So now I just plug in the values that I know. Looking at that triangle for phi, the red one, I know that sine of phi is going to be opposite over hypotenuse, 1 over radical 50, and cosine of phi is going to be adjacent. That's -7 over radical 50. Now looking at the blue triangle for theta, I can see that cosine of theta is going to be 2 over radical 29, and sine of theta is going to be 5 over radical 29. So what do we get here? When we do the big multiplication, you're going to get some fraction, which is, 50 times 29. You can figure that out in the radical sign. And on top, I have 2, forgot the plus sign, 2 plus -35. So that's actually going to be 2 minus 35, which is, -33. That part's not too hard. -33 over, I think 1450. Might be wrong, but I think that's 1450. And now, remember, that's sine of the angle, and I wanted cosecant of phi plus theta, which means we just flip that fraction upside down, and we're done. Okay, that's going to be the square root of 1450. I really think that could be simplified. I'm sure of it. But for now, I'm just going to say this, and if you want to simplify that radical, see what that can turn into, maybe factor it into a factor tree. I think 25 is a good idea to try. You could simplify this a little more.